Hello and welcome to the conditional probability test review. This is our first problem here where we're spinning this one and then we're spinning this one. So these are each 1/6, this is 1/2, these are each 1/3. So I made my tree like this with 1/6, 1/6, 1/6, 1/2, and then 1/3 coming off of there. The first question says what's the probability of them being the same color twice? They could be the same if it was green, green, so these you get to multiply to be 1/18. This one would be blue, blue, 1/6 times 1/3, and this would be red, red, which is 1/2 times 1/3, which is 1/6. When you're adding fractions, we need to change to a common denominator, and then add the top, so 5/18. The second question says, if you know you spun the same color, so that's the condition, what's the probability? It's blue, that's the event. So again, on our multiplication rule, says A and B would be in the top and just B in the bottom. So the probability of the same we figured out right here, so this goes in the bottom. The probability of blue and same would be blue and blue, which is 1/18. Remember that when you divide, we need to flip the second one and multiply. The 18s cancel and we get 1/5. Problem 2. We put in the information and then subtract, so this is what the table should start to look like. It asks what's the probability somebody bought a printer given they bought a computer. Printer given a computer. So we're not talking out of the whole 233, we're only looking out of the people that bought a computer. Out of these 126, 30 of them bought a printer. What's the probability somebody bought a computer or a printer? Well, I know with OR problems I need to take all the printer people, 44, plus all the computer people, 126, but I double counted these 30, so I'll subtract the 30, so I end up with 140 out of 233. Soda company, first thing to do is to do all my totals. Then the probability that it was soda C or under 20 was just like the problem before. I take all the people that are under 20, this is 200 of those, plus the people that like soda C, which is 228, but these 126 I have double counted, so I need to subtract those. I get 302 out of 800. B, what's the probability A was chosen? Well, that's easy. That's 326 out of everybody, out of everything. If they chose A, what's the probability that they were 60 years or older? So now we're not talking out of the 800. I know first that they liked this, so there's 326 of those people. And how many of these people were 60 and over? 141 out of 326. What's the probability the participant was 60 years or older? So that's just these people, 200 out of 800. The next one is that they were in this age group and like soda A. So those people would be in this age group and they like soda A. So those 67 people are in both categories. So 67 out of the 800. Notice it's always out of 800 unless it's a conditional probability. This is asking to prove if it's independent. So I know that there's an independence formula, probability of A given B equals A. So I'm going to set it up first, probability of 60 given they like A. Does that equal being 60 or older? This one I already found up here, right here. So I'll just put those numbers in. This one I found right here. I'll put those numbers in. And it looks like they are not equal, which means it's not independent. They are associated because normally your probability of being 60 or older is 25%. But out of the group of people that like soda A, that goes up to 43%. So you're more likely to be old if you like soda A. Maybe it's a ginger ale or something that old people like, but that means that they are associated. Moving on. We've got TVs or no TVs, DVRs or no DVRs. 95% have at least one TV, so that's my total of the TVs. 70% have a TV and a DVR, so that's here. And it says everyone that owns a DVR also owns a TV. So this category here of DVR but no TV has to be 0 because nobody's going to have a DVR player if they don't even have a TV. So then I do my totals. The probability that it has a DVR given it has a TV, it's out of the TV crew. There's 70. Are they mutually exclusive? Yes, see that 0? That means that they can't happen both together at the same time. So nobody has a TV but does not have a DVR. They do not happen at the same time, so they are mutually exclusive. Are they associated? Well, again, I'm going to go back to my formula. Does A given B equal A? A given B is this one. The normal probability of having a DVR and is 70%. So these are not equal. They are associated. That means you are more likely to have a DVR player if you have a TV, which makes sense. The last one here is about lie detector. So it says that people are lying 15% of the time. So maybe this is the person lies 15% or the person tells the truth 85%. But then the device will either be correct or incorrect. And it'll be correct 80% of the time. So it'll be correct 80%, incorrect 20, or 80 correct, incorrect 20. Then what I did here is I just kind of categorized it. Here, the person lies, and this is correct, so the polygraph is going to say that it's a lie, and that will happen 12% of the time because I multiply these numbers. The person lies, and it's incorrect, and it says he actually tells the truth 3% of the time. The person tells the truth, and the polygraph is correct, and the polygraph says he's telling the truth, and that will happen if you multiply these numbers 68% of the time. And the one we're trying to find is the person tells the truth, but the polygraph is wrong, and the polygraph is saying he's telling a lie. So you multiply these, that's 17%. So that's the worst thing that can happen. 17% of the time, the person's really telling the truth, but the polygraph is showing it's a lie. And that's 17%. I hope this helps.